Okie doke. Today we're talking about 1.4 and 1.5. And I think it's pretty easy two sections. 1.4 is equations with radicals in them, and 1.5 is inequalities. So we're just going to touch both of those sections rather lightly. Two notes about solving radical equations. Number one, you must isolate the radical before raising both sides to a power indicated by the index. What the heck? That's one of those math sentences you have to read 2 or 3 times. But if you have, for example, square root of x equals 9, how do you unsquare root something? You just square both sides. You can square both sides or cube both sides or raise both sides to any power you want. This note is just saying before you raise both sides to a power, you need to have the radical by itself. So number 12, when we get to it, we're going to have one step we have to do before we can cube both sides. And then note number 2, if you raise both sides to an even power, there's something you have to watch out for. You may get answers that look good but don't actually work. What's that one other time that we worked and we didn't make any mistakes and we got an answer but we couldn't use it? When we cleared fractions out of an equation, we had to see if our solution made any of the denominators 0, and if they did, we just had to mark them out, couldn't use it. So this is the second time we could not do anything illegal, but still get an answer that doesn't work. For example, if I have a square root of x equals -9, and I'm not really paying attention and I square both sides, I'm going to get x equals 81, and I should not have written on my original equation. I'm going to get x equals 81, but does that check? Is the square root of 81 -9? No. That symbol, that radical symbol, means the positive square root. If I wanted the positive or negative square root, I'd have to put a plus or minus in front of it. So that's just an example of how you can square both sides and get an answer that doesn't work. You just have to mark it out and write no solution. Now that doesn't happen when you raise both sides to an odd power. So you're really just watching out for that when you raise both sides to an even power. For example, number 8, I want to unsquare root 3t plus 4. You unsquare root by squaring both sides. I do have the radical expression by itself. Make sure you look out for that. I do have the radical expression by itself, so I'm going to go ahead and square both sides, and it's a really, really good habit to never write on your original equation, because you're gonna have to check your answer back in your original. What's the square root of 3t plus 4 squared? Just 3t plus 4, because the square and the square root undo each other. That's what you wanted to happen. 3t plus 4, and on the right-hand side, 2 squared is 4. Now, what kind of equation is that we're solving? Doesn't have an x square in it, only has an x to the first or a t to the first. What does that mean? It is linear. It's a linear equation, a first degree equation. We don't have to get it set equal to 0. We just need our variables on one side, our constants on the other. So subtract 4 from both sides. What do you have when you subtract 4 from the right-hand side? 0. Is that a problem? No, that's not a problem. 0 is just as good an answer as any other, as long as it's not in my checkbook. Divide both sides by 3, and what is 0 divided by 3? It's 0. Now, because we squared both sides of the equation, I'm going to check that answer and make sure that it is an actual solution. I think I've used this word before, but extraneous means looks good but doesn't work. We need to see if it's an actual solution or if it's an extraneous solution. So let t equal 0 back into the original equation, and you'll have 3 times 0 is 0, 0 plus 4 is 4, and square root of 4 is 2. So that checks. If the equation is as simple as square root of something equals a constant, then you can just go with the rule, as long as that constant is positive, there's going to be a solution. And if that constant is negative, there's not going to be a solution, because you'd have square root of something equals a negative. Square root of something doesn't equal a negative. But if the problem's more complicated, then you can't just say if there's a negative on the right-hand side. It's good to go ahead and check your solution. All right, number 10. If you're really on the ball, what can you tell me already? That's not going to have a solution, because this symbol means positive square root, and the positive square root of something can't be negative 2. So if you're watching out, you can go ahead and not write down any work, but just say no solution. If you happen to forget, then square both sides, and you will get an answer. You'll have 5t plus 3 equals 4. Then subtract 3 from both sides and divide by 5. And I get t equals 1/5. But I have to hypnotize you here again. Whenever your brain says square both sides or raise both sides to any even power, you have to check your answer. So substitute that 1/5 back into the original equation. 5 times 1/5, that's just 1. 1 plus 3 is 4. But is the square root of 4 negative 2? Not the positive square root of 4. So either you go through all that work and then realize your answer doesn't work, so there's no solution, or you pay attention right off the bat and know that that's not going to have a solution, because it's just square root of something equals a negative, and that can't happen in the realm of real numbers. It can happen with imaginary numbers, but we're not dealing with imaginary numbers here. Yes, sir.
If that radical had the parentheses negative out front.
Absolutely. And if that was the case, the first thing I would do is divide both sides by -1 to get the radical by itself. And then on the right-hand side, the negative divided by a negative would give me a positive on the right-hand side. But you're absolutely right. All right, number 12. My printer was having a little bit of issues the day I printed this. That's cube root if it didn't print clearly on your paper. How many terms are on that left-hand side? Good job. All of this that's held together under the radical, that's all one term. Cube root of 1 minus 2x is one term, and -1 is the other term. So if I were to cube both sides right now, I'd be cubing a binomial. To cube a binomial, you have to write it down 3 times and multiply it out. That would be pretty ugly. It would be legal. I could do it, but it would be ugly. It's much less ugly if I remember this note number 1, get the radical by itself before you square or cube or whatever you're going to do to both sides. So what do you think's the first thing I should do on number 12? Just add the 1 to both sides. Now I'm no longer cubing a binomial. I just made the problem so much easier. I can cube both sides. On the left-hand side, what's the cube root of 1 minus 2x cubed? It better just be 1 minus 2x. And on the right-hand side, 1 cubed is just 1. And then I'm just solving a linear equation. Subtract 1 from both sides. I have negative 2x equals 0. Divide both sides by negative 2, and I have x equals 0. You should never get an extraneous solution when you're solving an odd when your index is odd. If you get an answer that doesn't check and your index is odd, then you've made a mistake. It's supposed to check. Number 14 is a fifth root. Guess how to un-fifth root something? This is not even exciting, is it? Just raise it to the fifth power. Good thinking, but this is an odd power, an odd root. Yeah, it's good that you were thinking of that, but it shouldn't apply here because that's an odd root. All right, on the left-hand side, fifth root of 2x minus 3 raised to the fifth power is just 2x minus 3. And on the right-hand side, negative 1 to the fifth. What's negative 1 raised to any odd power? Negative 1. Any negative 1 to any even power is positive 1. So this is negative 1. Add 3 to both sides and divide by 2. You can go ahead and check that. Anytime I solve an equation, especially on a test, I'm going to check my answer. If you let x be 1 here, you will have 2 times 1 is 2, and 2 minus 3 is negative 1. Is the fifth root of negative 1 negative 1? Yes, it is. So 1 is the solution. What is number 36 even doing in a section titled Radical Equations when it doesn't have a radical in it? Because that exponent 1/3 means what? Right, good job. That means the same thing as cube root of 2x plus 1. You don't actually have to write it as cube root. If you want to leave the exponent 1/3, that's fine. You just have to know how to undo that exponent 1/3. What would you do to both sides of the equation? Raise it to the third power. Raise it to the third power. So take what's already there. Raise it to the third power on both sides. Here's good proof that all of the rules in math mesh together and support each other. You already know that cubing undoes cube rooting, but by the same token, if you use your rules of exponents here, when you raise a power to a power, what do you do with those exponents? You multiply them, and guess what 1/3 times 3 is? 1. So that's just more proof of why the rules for exponents are what they are. That left-hand side's just 2x plus 1. Right-hand side, negative 1 cubed is negative 1. Subtract 1 from both sides. Oops. And then divide both sides by 2. Is there any possibility of that solution being extraneous? No, because this was odd root. You could still check it, and I would still check it. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. And then the cube root of negative 1 is negative 1. So that checks. There's actually one other thing in this section. This section is titled Radical Equations and Factorable Equations. We've looked at the radical equations. factorable equations are just higher order equations, some power higher than 2, that still can be solved by factoring. And just like quadratic equations, the first thing we have to do is get it set equal to 0 and then factor completely as possible using all the techniques for factoring you already know. First thing you always look for is what? When you're factoring? GCF, look for a GCF, and then see if you're left with the difference of 2 squares or a perfect square trinomial or whatever. Factor as completely as possible, and then set each factor equal to 0. So number 24. Yes, you're right, number 44. It's not a quadratic equation because it's 4th degree, which actually sounds like that should be what a quadratic equation is, but it's not. It's a 4th degree equation. I could treat it like a quadratic equation. What's the only question I would have to ask myself in order to know whether or not that would factor? It begins, are there close? There was only one mistake in that. I don't need factors of 12. I need factors of 24 because this is the hard kind of trinomial. Multiply the 2 times 12 and look for factors of 24 that have a difference of 5. Now, y'all did well on that factoring. If we finish a minute early, there is one problem on the test that so many people missed. I do want to work it, but you did well on your factoring. I was proud of that. Factors of 24 that have a difference of 5, can you think of them? 8 and 3, 3 and 8, doesn't matter which order you write those in. It matters that you get the signs correct. In order to get a negative 5, what do those signs have to be? A negative 8 and a positive 3. That's right. And what do you do with that negative 8 and positive 3? Split the middle term. All right, so just bring down the 2x to the 4th, but split that negative 5x squared into, it doesn't matter if you write 3x squared minus 8x squared or negative 8x squared plus 3x squared. You're less likely to make a sign mistake if you put the negative first. It works either way, but if I have a positive and negative, I always put the negative first. And some of you do this by trial and error. That's fine too. I'm doing grouping for the folks who need it. All right, group the first 2 terms, group the last 2 terms, factor the GCF out of each group. What can you factor out of the first group? 2x squared. And what will that leave you inside parentheses? X squared minus 4. What can you factor out of the second group? A 3, and what does that leave you? X squared minus 4. Now I have a binomial. All of this that's held together by multiplication is the first term. This is the second term. What do both terms have in common? They both have an x squared minus 4. So x squared minus 4 is the GCF, and what are the leftovers? Good. Something else I'm proud of y'all for? You talk to me. I think it certainly makes the class more interesting for me. If I do all the talking, it's just boring. But I think it helps you too. When you talk out loud, it helps. You're involving that other sense that helps move the information from your short-term memory to your long-term memory. All right. Will that factor any further? Yep. X squared minus 4 is a difference of 2 squares. Yes, that's x plus 2, x minus 2. What about that second factor? Will it factor further? The only way I know how to factor a binomial is difference of two squares, and that's definitely not. So no, that one won't factor any further. After you have factored completely, set each factor equal to 0. Those first two equations are linear equations. What two solutions do they give you? Yep, -2 and +2, which that is not, by the way. I wrote a 3. That other equation is not a linear equation, though. It's a, what kind of equation? Quadratic. And you've already told me it won't factor any further, so what's the next thing I would try? Square root method. All right, try the square root method. Get the x squared by itself. X squared equals -3/2. What do you know about these two solutions now? If you square something and get a negative, it must be strange. Yeah, it's a strange number or an imaginary number. I didn't type the directions here, but in the book and in my math lab, you'll see the directions just say find the real solutions. If the directions say find the real solutions, then I don't care about the imaginary solutions. All right? Plus or minus I square root of 3/2 are two solutions, but they're not real solutions. The only two real solutions are the -2 and +2. On the test, you had some problems that just said solve, and almost everybody kept going when they were using the quadratic formula and ran into a negative under the radical. I'd cautioned you about that. Don't just stop and tell me no solution, because those directions said solve, which means find all the solutions, real, imaginary, whatever. All right, number 76. Dividing both sides by x cubed would be forgetting what important step? You've got to get it in standard form first. So subtract the 4x cubed from both sides. And factor it. What can you factor out? An x cubed. And what does that leave you inside the parentheses? X squared minus 4, which just so happens to factor further. When I set those three factors equal to 0, I know I'm going to get the same two solutions that I had in number 44. I know I'm going to get -2 and +2. What about that x cubed equals 0, though? Is there a solution to that equation? Yeah, 0 cubed equals 0. So 0 is one of the answers. It's just as good an answer as -2 or +2. No. In my math lab, they may have braces there for you, and you just fill in the braces. But if they don't, just list the solutions. All right, one more problem. Number 80 is a third degree equation. It's already in standard form, but how do I solve it? The only way I know how to solve a 4-term polynomial is by grouping. Group the first two, group the last two, pray that you end up with the same thing in both parentheses. Now, when you group the last two, be very careful with that negative. If you leave it outside the parentheses, it'll change the sign of the 4. Every line has to be equivalent to the line above it. And if you have that negative outside the parentheses and you distribute to check, you won't get back what you started with. What can you factor out of the first group? An x squared, and that will leave you an x plus 4. What would you have to factor out of the second group in order to also be left with an x plus 4? So your GCF is x plus 4. Your leftovers are x squared minus 1. And that quadratic factor will factor further. That's the difference of 2 squares again. When you set each of those equal to 0, what are your 3 solutions going to be? Yep. That set equal to 0 will give you negative 4. That would give you negative 1. That would give you positive 1. I just put the braces because I feel like being fancy today, but you don't have to. All right, that's all that's in 1.4. Pretty easy. How'd I get negative 4? If I set x plus 4 equal to 0, what would I have to do to both sides of the equation? Yep. Sometimes you just need to write it down to see it, and that's fine. Something else just occurred to me. I'm thinking about the mistakes you made on the test. Some folks did the wrong things on the problems that said factor and the problems that said solve. If, for example, I just have x squared minus 4 and say factor, you can't solve that. It's not an equation. It doesn't equal anything. You can factor it into x plus 2, x minus 2, but then you can't set each one of those equal to 0 because that's not equal to 0. So if the directions say factor, if you don't have an equation, then just factor and stop. A few of you had solutions, and I just made you a note, hey, this wasn't an equation. You can't solve it. And then on the problems that said solve, especially the one, I kind of remember the answer, 8k minus 1k plus 4 or something. A lot of folks, that was an equation, but a lot of folks stopped with just the factoring. If it's an equation, you can solve it. If it's just an expression, factoring's all you can do. All right, 1.5 is titled Linear Inequalities. What does linear mean? What does that tell you about the exponents? First degree. First degree, and inequalities tell you to be expecting what? Everything we've solved so far has been an equation. What's the difference between an equation and an inequality? The less than or greater than rather than the equal to. If you have always had trouble with inequalities, the way my children remembered it is the less than symbol is the symbol your left hand makes. Less than sounds like left hand, so that's how they remembered it. Greater than is the symbol your right hand makes. That works. Yeah, that works, but if you have algebraic expressions, I don't know which of these is the smaller number because they're just algebraic expressions, I still need to know that that's a greater than sign. But when you get down to numbers, you're absolutely right. So you have to have your less than, greater than straight. And then this, you need a microscope to read. It is on page 120 in your book if you need to look it up. But the only difference between our answers in college algebra than they may have been in your high school algebra book, you may have just stopped when you got to, for example, x is greater than 2. You might have just left it x is greater than 2 as your answer, and that's fine. But all the college algebra books and even a lot of high school books now are just writing the answer in interval notation rather than an inequality. It's easy because all you have to do is graph your answer, and the interval notation looks just like your graph. If you come up with, say, right here, x is greater than a, or let's do this one first. X is greater than or equal to a. Is that right there? Very hard to read. X is greater than or equal to a. If x is greater than or equal to a, which side of the a is it on the number line? Greater than would be to the right of a. And how far to the right? Keeps going forever. And what's that math symbol that stands for keeps getting bigger and bigger without end? Infinity. The infinity symbol. Yeah, turn your paper sideways and make an 8. So the interval notation, look at my graph here. I have a to infinity shaded. That's exactly what the interval notation looks like. That, and for those of you who can't see it, it's a comma infinity. Now, something else that may be a little bit different than you did in high school. In high school or 7th and 8th grade, do you remember open dots and closed dots? What did the open dot mean? Just greater than or less than, the endpoint itself was not included. Open dot means not including that endpoint. Even high school books and certainly all college algebra books now, instead of using open dot and closed dot, use parentheses and brackets. And I made you a note right here. Remember that parentheses mean not including the endpoint. They're just like open dots. And brackets mean including the endpoints. They're just like closed dots. So if you have the less than or equal to or the greater than or equal to, you'll use brackets instead of parentheses. And that's why right here, that interval notation that you can't see had a bracket on the A because the original inequality was x is greater than or equal to a. And the or equal to is what caused me to put a bracket on the A. But can infinity ever be included? Infinity is not a number. You can't get there and say, hey, this number is a solution. Because you can't get there and include it, I have you another note. Always use parentheses on infinity or negative infinity. So that's why this interval notation ends with a parenthesis on it. All right, since that's so hard to read, I'm not going to read it to you. Let's just do a couple examples on the back and see if we can get the hang of this interval notation. Illustrate each inequality on a number line. That means graph it. Write each inequality using interval notation. If I told you to graph this compound inequality, -1 is less than x is less than 5, where would you shade on the number line? Forever to the left and forever to the right. But this says x is less than 5. In between -1 and 5, not only does this say x is less than 5, but if you cover up the right-hand side, it means it says -1 is less than x, or if you read it backwards, x is greater than -1. So this compound inequality means shade from -1 to 5. X can be anything between -1 and 5. Does that include or not include the endpoints? Because the endpoints are not included, because you just have less than, not less than or equal to. In high school, you might have put open dots on the -1 and the 5, but here we're going to have, instead of dots, parentheses to show that the endpoints are not included.
You think of it as it has greater than or equal to in that. The brackets make an equal
Right? I see it. Yeah, that works. Whatever will help you remember. If it has the equal to, then it's brackets. The good thing about graphing your answer is the interval notation looks just like your graph. After you get used to interval notation, you won't have to graph it anymore. But in the beginning, if you're struggling with interval notation, just draw the graph and your interval notation looks just like it. That interval notation, I feel a sneeze coming. There are very few things in math that are ambiguous, can mean two different things. This is one of those very rare times of ambiguity in math. If we were on a section about linear equations, graphing lines, that looks like an ordered pair. All right? If I was graphing, I would say, hey, that's an ordered pair. But since I know that what I'm doing here is solving an inequality, I know that's not an ordered pair, that's an interval from -1 to 5. All right, number 28, x is less than 5, not equal to 5, just less than. To which side of 5 would contain all the solutions to that inequality? Oh, I don't know how it happened, but okay, that's very weird, but there you go. We can make it say that. To which side would you shade? All the numbers that are less than 5 are to the left of 5 on a number line, and that's what your shading represents. The part of the number line that contains the solutions. How about the 5 itself? If your paper says less than or equal to 5, does that include the 5? Yes, and how do you show that? With brackets. Now, when we were looking at the chart a while ago, we said if you shade forever to the right, you're going to use the infinity symbol. Guess what you'll put for forever to the left? Negative infinity. Yes, you can never have a bracket on infinity or negative infinity because you can't include it. It's not a number. So your interval notation is parentheses, negative infinity to 5, including the 5. One other thing about interval notation, it should always be smallest to largest. You wouldn't write 5 to negative infinity. You write it left to right, just like it comes on the graph. All right, one more. X is greater than 1. Is that what yours says? All right, would start at 1 and shade forever in what direction? To the right, including or not including the 1. Not, which you show with parentheses. And what symbol means forever to the right? Infinity. So that interval notation is just like the graph, 1 to infinity with parentheses on both of them. All right. The other thing, Miss Valerie, I could have sneezed. Yes, you do. And they rarely come in singles. I inherited that from my granny. If I sneeze once, I usually sneeze 3 or 4 times. I know this was odd. All right. Other than how you write your answer, interval notation. And by the way, on the test, the directions say write your answer in interval notation. If you stop with x is greater than 1, well, I'm happy that you got that far, and I'll give you most credit, but you're probably going to get minus 2'd if you don't write it in interval notation, because that's what the directions say. All right, the only other thing you need to know about solving inequalities, other than how to write your answer, is that it's the very same steps as solving equations. If you think back to that box that was on the 1.1 handout, you clear the fractions, combine like terms, get all the terms with an x on one side, all the terms without an x on the other, and then divide by the coefficient of x. It's the very same steps here, except for there's one hypnosis coming. The hypnosis session is whenever you multiply or divide both sides of an inequality by a negative number, what do you have to remember? Flip the sign. Or, in mathematically precise terms, reverse the symbol, because this less than is a symbol. When you say sign, I'm thinking positive or negative. It's a symbol, and you reverse that symbol. Does that sound like one of those things somebody made up a million years ago to see how many people they could make fail college algebra? Just sounds like one of those crazy random things. Nothing in math is crazy and random. That's why I like it so much. I like my life well ordered. Let me show you why it's not just crazy. If I ask you to put the correct inequality symbol between the numbers 1 and 5, what inequality symbol would go between 1 and 5? Yes, and I don't know why I was thinking greater than, but yes, 1 is less than 5. That's no, I don't know. That was post-sneeze syndrome. 1 is less than 5, and that's because 1 is to the left of 5 on the number line. That's why you have a less than there. However, if I look at -1 and -5, what inequality symbol goes between those two? -1 is greater than -5. This inequality, these numbers are the same as these numbers multiplied by -1, but sure enough, the order in which they lie on a number line has changed. The -1's not on the left anymore. If you make a number line, -5 is to the left of -1. And that's when you multiply or divide both sides by a negative, you have to reverse the symbol just because of the way negative numbers lie on the number line. So if you've been holding a grudge against somebody for years for doing that to you, get over it. All right, here's a linear inequality. Same steps as solving an equation. I don't have any fractions to clear out. I don't have any parentheses to clear out. I don't have any like terms to combine. So the first thing I do is what? Subtract 2 from both sides, and -38 minus 2 is -40. And then what? Divide by -10, and as soon as your brain thinks the words divide by negative, what bells and whistles go off? Reverse that symbol. If you have negative at negative 10x is less than or equal to negative 40, then the solution's going to be x is greater than or equal to 4. All you have to do is pick a number bigger than 4 to see if it works. If you try, let's say 5, you're going to have negative 50 is less than negative 40. That's true. If you pick a number smaller than 4, say 3, you're going to have negative 30 is less than negative 40. That's false. Negative 30 is bigger than negative 40. So that's the solution. That's your answer in interval notation. Oh, where did that go? Is it the same way on your paper? Does your paper have the equal to on the very first line? What the heck? I'm telling you, I had printer issues that day. The original problem was supposed to have an equal to. No, they don't hocus pocus appear and disappear unless you're using my printer on that particular day. That's not a precise statement, Kevin, because if you divide a positive by a negative, you get a negative. Yeah, but I don't get where what that has to do with reversing the symbol. You reverse the symbol whether this number turns out to be positive or negative. The sign of this number has nothing to do with the direction of that symbol.
So you reverse the sign if that was positive 40 divided by negative 10, if negative 40, still reverse the sign because you're divided by a negative.
That's the key, dividing by a negative. It doesn't matter if you end up with a positive or negative number on the right-hand side. If you...
Right. X is positive, we divide by it.
Exactly. Might even want to highlight that. If you multiply or divide both sides of an inequality by a negative number, you reverse the inequality symbol. And that's the only time you reverse it, if you multiply or divide by a negative. All right. Number 60. This is so easy, I'm embarrassed. Don't have any fractions, don't have any parentheses, don't have any like terms to combine. So what? Add to. I was thinking about my x's first. By the way, it doesn't matter. Just like an equation, it doesn't matter if your x's end up on the left or right. You just have to make sure that you read it correctly if your answer ends up on the right. I usually get my x's on the left with inequalities, so I would subtract x from both sides, and I could go ahead and add 2 to both sides while I was at it. That gets my x's on the left and my constants on the right. 2x minus, doesn't it seem like 2x if you take away the x should just be 2? That's one of those things. That's one of those things you have to get over in about the 7th grade. 2x minus 1x is 1x, and of course you don't have to write the 1. X is greater than or equal to 5. Now, I don't care if you graph it or not. I don't ask you to graph it on the test, but if you need to graph it to make sure that you get your interval notation right, then go ahead and graph it. X is greater than or equal to 5 would start at 5, shade forever to the right, and include or not include the 5. Include because that was greater than or equal to. And the symbol for forever to the right is infinity. So my interval notation looks just like that. From 5 with a bracket on it to infinity with a parenthesis on it. Number 64 has a most common mistake. I know none of you would make it because y'all are algebra geniuses. But can you guess what some lesser algebra person might do? That's the most common mistake. And it's reasonable. I mean, I see why you might say, oh, 8 minus 4 is just 4, and distribute the 4. But the order of operations says you have to do multiplication before subtraction. So you have to distribute that negative 4 and then combine like terms. Negative 4 times 2 is negative 8. And negative 4 times negative x is positive 4x. This problem also confuses folks because all of a sudden you don't have any constants. That 8 minus 8 is 0, and you just have 4x is less than or equal to negative 2x. What do? Not 2, but 2x. Yeah, you just add 2x to both sides, and what does that leave you on the right-hand side? Sure. Don't be afraid of zeros. If you have 6x is less than or equal to 0, what does x have to be? Less than or equal to 0. In other words, 0 and all the negative numbers would make that original inequality true. Yep. It's pointing to the left. So 0 and forever to the left, and the symbol for forever to the left is negative infinity, a bracket on the 0 because that inequality was less than or equal to. And then that's exactly what your interval notation looks like. Parenthesis on negative infinity, bracket on 0. No, make sure you shade it the right way though. If you come up with 0 is greater than or equal to x, some folks will look at that greater than and still shade to the right. If your x is on the right, you need to read it backwards. That still means x is less than or equal to 0. So if I ever come up with my variable on the right, I pick the whole thing up and flip it over just to make sure I shade the right way. Is that okay? Yeah, with equations it doesn't matter because an equal sign is the same thing for upwards and backwards. But with inequalities, I prefer to get my x on the left. All right, number 68, one of your favorite things, clearing fractions. And the problem I think we'll have time to do from the test in a few minutes is similar to that. A little bit uglier than that, but you remember that equation? It said solve the equation. It had fractions in it. Few people got it right, and it tickled me to death. Most folks did not, so I want to show you. How do you clear fractions out of an equation? Not GCF, but LCM or LCD. You multiply both sides by the lowest common denominator. Does this look more like a 2 or a 3 on your paper? Okay, that's what it kind of looks like to me. So the LCD is what? 6. Multiply both sides by 6. Is that going to reverse the symbol? Not if I'm multiplying by a positive 6. Multiply by 6 over 1. On the right-hand side, I could either leave the 6 outside parentheses, or I could go ahead and distribute it. Make sure I multiply the 2 by 6 and the x over 6 by 6. Notice that when I'm multiplying by a fraction, I write it 6 over 1. If I'm multiplying by a whole number, I just write 6. It's the same thing. What I'm not doing, though, and this is a mistake some folks made on the test, I'm not multiplying this just by 2 over 2 to make it have the common denominator. I'm not trying to get it to have the common denominator. I'm trying to get rid of the denominators. You can only do that in an equation or an inequality, and you do it by multiplying by the whole LCD, not just what it needs to make it have the LCD. On the left-hand side, 3 goes into 6 2 times, so all that's left is 2x is greater than or equal to what? Twelve plus x. And then what? Subtract x from both sides. You have x is greater than or equal to 12, which starts at 12 on the number line, includes the 12, and shades forever to the right. Excuse me. Which is infinity. So that's exactly what your interval notation looks like, from 12 to infinity with a parenthesis on it. All right. Any questions? Last two examples have compound inequalities, and actually, I've already used that word. This is a compound inequality. A compound inequality says two things. This number 24 was saying x is less than 5, and at the same time, it was saying -1 is less than x, or you can read it backwards, x is greater than -1. Those two things mean the same. So number 72 is saying two things. I could take that apart into two inequalities if I wanted to. If it made it easier for me, I could. Or I can think of it as being like an equation with three sides. Whatever I do to one side, I have to do to all three sides. And I'm trying to get the x by itself. It's in the middle. Let me just cover up this left-hand side for a minute and say, if that were all there was to this equation, what's the first thing you do to both sides? You'd subtract the 3 from both sides to get the -2x by itself. Well, do the same thing here. Subtract 3 from all three sides. I don't usually write it like that. I don't like that. It's hard to tell that I'm subtracting 3 from all three sides. On the left-hand side, -3 minus 3 is -6. In the middle, if I subtract 3, I'm just left with -2x. And on the right-hand side, 9 minus 3 is 6. Then what? And as soon as you said divide negative, bells and whistles went off to remind me, reverse the symbol. Divide both sides by -2, but that is going to reverse the symbol. So -6 divided by -2 is 3, and 6 divided by -2 is -3. If you graph that, make sure you have -3 to the left of +3 on a number line. And in your interval notation, because your interval notation should always be smallest to largest, or left to right on a number line. Include those endpoints, shade between, and that's exactly what your interval notation looks like. Bracket, -3 to 3, close bracket. All right, 82 More fraction practice. And what in the world are those denominators? Is this 3, 2, and 3? Ugh. So what's the first thing I need to do? The LCD is 6. And do what with it? Multiply all 3 terms or all 3 sides by 6. 1/3 times 6. Put it over 1 if you want to. X plus 1 over 2 times 6. And 2/3 times 6. When you're solving an equation with fractions in it, your next line should not have fractions in it anymore. That's the purpose of multiplying by the LCD. This left-hand side, 1/3 times 6 is just 2. In the middle, I can say 2 goes into 6 3 times. And to save a step, I'm going to go ahead and distribute that 3 completely. 3x plus 3. On the right-hand side, 2/3 times 6 is 4. And then what? Subtract 3 from all 3 sides. 2 minus 3 is -1. In the middle, I'll just have 3x. On the right-hand side, 4 minus 3 is +1. And then what? -1/3 is less than x is less than or equal to +1/3. On your paper, did one of those have the equal to and one didn't? Okay. You put a parenthesis on the -1/3 because it's not included, and the bracket on the +1/3 because it is included.